Welcome to the lecture series on soft computing in computer science. This lecture we are going to discuss about the topic fuzzy rules and reasoning. Before getting into the topic, you should know what is a rule and how a rule is represented. So here are some examples for a if then rule. If pressure is high, then volume is low. If road is slippery, then driving is dangerous. If your tomato is red, then it is ripe. If the speed is high, then apply the brake a little. So, if you could see that there are two components in a rule. One is called a if part, another one is called the then part. In all the cases, if part is explained by some metric as well as the then part is explained by some metric. So, if you could observe that when this is happens, that means if the road is slippery, if this is happen, then automatically this also is expected to happen. So, in this way you can understand the each and every if then rule as a conditional statement. If this condition becomes true, if the speed is high, then automatically you should give a alarm, that then automatically it should give an indication that you should apply a brake a little or according to the situations. So, these are all the ways in which a conditional statement can be represented in the form of a if then rule. Then comes the formal definition for a fuzzy if then rule. So, in the previous topic we have discussed about relation. So, this fuzzy if then rule can also be represented as a relation between two rules, between two variables. So, what are the two variables? If then y, right. So, it is again said that these two variable can be represented in the fuzzy if then rule as a fuzzy relation, and this relation is a binary relation and it is represented as x cross y. So, strictly speaking, a fuzzy rule is otherwise called by the name fuzzy implication or fuzzy conditional statement. It is represented as a relation between two variables. One is the variable in the if part, another one is variable in the then part, and this relation is termed as a binary fuzzy relation, capital R. So, what is the general format of this rule? If x is A, then y is B. It is represented as A tends to B. That means, if you take any variable x, if x is A, then for the same similar kind of situation, the response y is B. Here this x is A is called by the name antecedent or premise, and y is B is called as consequence or conclusion. So, this is you should remember very clearly, and this fuzzy if then rule is also called by the name fuzzy implication or fuzzy conditional statement. So, if x is A, then y is B. So, it is very shortly written as A tends to B. So, this is the formal definition for if then rule. Now, there are two processes that has been involved in the concept of fuzzy if then rule. Let us take an example. If the profession is athlete, then fitness is high. Let us take this example. From this example, let me try to explain what is meant by coupling and what is meant by entailing. Coupling is a kind of idea that has been already inbuilt in it. That means, say for example, if you ask a person, what is your profession or what are you doing? He says that I am an athlete by nature. So, what you will do automatically and what you will accept automatically? Oh, definitely your stamina is very great, you are a very fit individual and you have a very strong muscles, like that and all we can start doing, start discussing like that, right. So, if it is athletes and if the person is athlete only, then it is highly understood that he has a fitted physical muscle, right. So, now here this coupling state that the if statement is antecedent, that is itself sufficient to convey the fitness of the individual. So, the if statement alone is sufficient, and here the condition is more than sufficient enough to idea to understand the. So, this is called coupling, right. So, what is entailing? Entailing. So, if you could observe this statement, athletes have high fitness. It means that if you are not athlete, if you are not an athlete, then your fitness is a question mark. It need not be you are a fitted individual and your fitness is also, and you are a weak individual maybe, right. So, in that case all the athletes, it is understood that they have a strong fitness, and on the other hand, as an against contradictory, a non-athlete may not have a high fitness. So, in this case the if condition alone is sufficient and no need for the necessary then condition, right. So, this is an example for coupling and entailing that is very well hidden in the fact of if then rule for a certain if then conditional statement. Let me explain how to interpret this coupling and entailing, right. So, there are two ways to interpret that if x is A and y is B. Let me first explain what is A and why it is said as A is coupled with B, and another one how A is entails B. Let me take an example. See, look at this figure, right. Here if x is A intersection y is B, take this example, x is A, right, x is A, but it should be intersected with y is B. So, it means that we need a region that is common to both A and B, where A is intersected with B. In this curve, if you take this A and B is intersected here. For such kind of conditional statement, we need a bell shaped MF and T norm operators. So, while you are going to design a if then rule into a fuzzy system, you should understand the coupling and entailing factor of a conditional statement, particularly the if and then part, and based on that you should decide the corresponding membership function. So, in the previous lecture we could see that we have given lot of membership functions that characterize the given condition, right. So, accordingly you should choose for this particular condition what MF is hold good, well shaped MF is holding good. It means that only fit athletes satisfy the rule, right. If the person is athlete then he is strong, right. It means that only fit athletes. There are some athletes they may also not fit enough, so only the fit athletes will, right. Next come to the another condition, A entails B, A entails B. It means that X is not A but Y is B. That means X is not into the category of athlete, but still he is fitted. It means that you need to take a union. X is not A, wherever the A portion is there you need to include, and you should include all the portions where B is there, where B is there. So, this is the condition, X is not A. For this case it is sufficient enough only the bell shaped MF. And how to arrive at or how to have an idea about which MF is suitable for the kind of conditional statement. Over the period of experience, when you dealt with a lot of conditional statement like this form, and by applying the coupling and entailing factor, so you have a definite idea about what kind of MF is suitable for representing that situations. So, for this case if A entails B, if you could see that everyone except non-fit athletes satisfy the rule. So, this is the way in which the entailing factor is working out. Next, compositional rule of inference. So, ultimately what is our aim and what is our objective? The conditional if then statement should provide an inference so that the inference system will work out. Accordingly we will receive the output. Now, let us take an example, right. Let me take an example like A and B are points, right. I have a point A as well as I have a point B, right. Now, I have a curve f of x, y equal to f of x. Here I have a curve y equal to f of x, right. Now, if I know A, if x is equal to A, right, how can I derive B? Simply by taking the value where it cuts the point in the curve. So, accordingly I can take the value of B. So by knowing the a value as well as by knowing the a equal to f of x, so definitely I can derive what is b. So and it is a single value, right. Now let us take in the second one. Suppose if a and b are intervals rather than a and b are points. Suppose a and b are intervals like this, a and b are intervals. In this case, how can I decide? Now this f of x has to be chosen as a interval valued function, right. In that case, if I want to mark a, so the boundary of a is lie within this limit. So accordingly I should decide the b value, the b value is like this. So this is called a fuzzy rule. See, I cannot give guarantee, that means I cannot give a exact point where and a and b, but I can give a interval valued function where this a is there, corresponding b should be there. So that idea plays a vital role when you want to compose any rule for understanding the idea or bringing out some inference over the conditional statements. Fuzzy reasoning. So once you are understand the idea about what is a conditional statement, what is a fuzzy implication, and how you represent the fuzzy implication. How you represent the fuzzy implication? A fuzzy implication is represented in the form of a if then conditional statement. Okay, now I have lot of conditional statements based on the experience or based on the data or based on the environment, based on the situations. I have lot of conditional statements. But when these conditional statements are to be reasoned, have to be composed to derive the inference, then only the actual system is working. So fuzzy reasoning is nothing but a kind of approximate reasoning. Simply speaking, it is a inference procedures that tries to get the output, that means that tries to get the conclusion from the set of if then rules. All the if then rules are here are treated in the form of a facts. So based on the given facts, I need to derive the conclusion. How? Fact is given, according to the fact I need to derive the conclusion. So this process is called, from the fact deriving the conclusion. This is going to be called reasoning. This is what the human being is doing. You remember the first lecture about fuzzy logic, why human is very good at understanding certain vague idea, uncertain values, because human is having common sense and he is having the reasoning capacity to conclude about the situations, right, whenever some statements are vague in nature or uncertain in nature. So that reasoning mechanism has to be brought to here when you apply fuzzy for some sort of conditional statements. How? See, the conditional statements are treated as fact. From the fact you are going to derive a conclusion, and this process is said to be called reasoning. And since this process involves a vague and uncertain situation as well as non-crisp boundary, and it is said as fuzzy reasoning. And this fuzzy reasoning, and for this fuzzy reasoning to get executed and to get performed, you need the idea of compositional rule of inference. So using the compositional rule of inference, what you can do? You can derive an inference precision over the set of rules. So there are lot of inference procedures are available. Based on the inference procedures, you may define or you may formally define how to execute or how to fire a if then rule in order to produce a definite conclusion. So this is what the fuzzy reasoning is all about, right. So this fuzzy reasoning or the concept of fuzzy reasoning with the idea of if then conditional statement can be understood or can be understood with the help of single rule with a single antecedent, single rule with multiple antecedent, multiple rules with multiple antecedent. That means single rule, you have only one rule, that is if x is a then y is b. This is single antecedent, right. If single rule, if x is a then y is b and z is c. This is single antecedent, single rule with multiple antecedent. What is multiple rule with multiple antecedent? If x is a comma y is b, then p is q, r is s, like that. So it means that the number of variables that are present in the if part, that means consequence, as well as in the antecedents. So that is what you need to think. If only one variable present in the both if part as well as in the then part, then it is single rule with single antecedent. If one variable in the if part and more than one variable in the then part, then it is single variable in the multiple antecedent. If more than one variable in the if part and more than one variable in the then part, then it is going to be the third case. Now we are going to deal with case by case and how the case is executed or fired in order to produce a definite conclusion, how it is carried out. So that is what we are going to see. Single rule with single answer. As I said earlier, if x is a, then y is b. What is premise here? X is a dash, where the value a dash. So when you want to fire this rule, you are supposed to give a value that are more or less are related with or close to a, right? Then y is b dash, right? So always it is not necessary that you should give only a and you should expect only b. You should submit a value that is closer to a, that is a dash, and closer to b, and that is b dash. So that is the premise and conclusion. The rule is like this. So I infer that rule, that means I apply that rule by means of composition of inference idea. For any premise and conclusion, I can execute that rule. For doing so, what I have to take? I have to take a intersection. Over the intersection, I have to take the maximum value between a and a dash to get b dash. So this is the idea with single rule and single answer. Let me explain this further with the help of an example. Now I have two. So actually, if x is a, this is the actual rule. If x is a, then y is b. This is the actual rule. Now my value is a dash, not a. If x is a dash, my value is a dash. This is the actual rule, but over the actual rule a, since my a dash is very similar to a, I have to plot this a dash. Maybe for this example, I have taken a bell shaped MF. If you could see that, see this bell shaped MF has been cut with in this point, right. So in this overall b value, my a has cut in this. So the weightage is like this. So this is b dash. So likewise, I have to derive the conclusion. So for a standard rule of this thing, if x is a, then y is b. If you apply x is a dash, then y is b dash, then the situation is like this. Then the situation is a single rule with a single antecedent. Right. Let me go to this next one. Single rule with multiple antecedent. If x is a, then y is b and c. Right. Sorry, multiple antecedent. X is a and y is b, then z is c. Or other hand, if x is a, then y is b and z is c. That situation. Here, since this case is taken as x is a and y is b, the premise is x is a dash and y is b dash. Both are in the premise part. If that is the situation, my conclusion is z is c. So in that case, I should apply min. So if you could see that a intersection a dash, b intersection b dash. So a intersection a dash, see now my a is very similar to a dash is very similar to a, as well as my b dash is very similar to b. So what I have to take? I have to take the value that are common to both a and a dash, and I have to take a common value between b and b dash. Then I have to take the minimum value in order to get the c dash. Look at the picture here. See, I have two things. One is a, if x is a, another one is y is b. Multiple antecedents, right? So in that case, my x is a and y is b is there. But what is my actual value? X is a dash and y is b dash. Now I should map this value to the actual rule. I should place this a dash over a. I should place this b dash over b. If I place like this, see, B dash goes to B and A dash goes to A. If you place like this, see, this is the portion, see, I shared this portion, this is the portion that is taken as A intersection A dash. Likewise here, this is the portion, this is taken as B intersection B dash. Among these two portions, A intersection B dash, B intersection B dash, what I should take as per the composition rule of inference? Let me recall here what I should take, minimum value. So here if you look at this picture, I have two values, one value is this, another value is this, right. B dash is interfering with the B here, right, and A dash is interfering with A here. If I take that corresponding value, now which is having the minimum value? This one is having the minimum value. So that thing is derived as a C dash. That is derived as. Now I hope you understand the idea behind this. So you should fire the actual value with the existing rule and take the cut points, and wherever the cut points is there, you take the corresponding value, and from the corresponding value you should take the minimum value as per the. What about this case? In this case you should take the maximum value. This is for single rule with single antecedent, but this is single rule with multiple antecedent. Let me go to the third case, multiple rules with multiple antecedent, right, more than one rule, right. If x is a1 and y is b1, one rule, z is c1. Let me take another rule because it is multiple rule, right. Rule 2, x is a2 and y is b2, that is the another rule, then z is c2. So this is two rule, that means multiple rule, and each rule is having more than one antecedent. See, this is a1 b1, rule 1 is having, rule 2 is having a2 b2, right. So what are the premises here? X is a dash and y is b dash, z is c dash. So this is what we need to apply. So what do you have to do? We need to consider the max of c1 dash and max of c2 dash in order to get c dash. So this is the rule of inference, compositional rule of inference. So you are provided with the two rules, and in that rule each rule is having multiple antecedent. Then for a given premise a dash and b dash, you need to conclude c dash by taking maximum of c1 and c2. Let me explain this with a diagram. Now if you look at this diagram, here I have this one, see, x is a1 and y is b1, this is one rule. Another rule, this is rule 1. Another rule, if x is a2 and y is b2, this is another rule. Here it is c1 and here it is c2, right. So this is quite naturally the existing rule statement. Now what is my actual value? Here x is a dash and y is b dash. So y is b dash, fortunately it is a grist value, say for example it is a grist value. Now what I have to do? I have to map this actual value with over rule 1. Rule 1 where it get pointed out? Here it is pointed out. So this is the common value, this is the common value. Accordingly this grist value is pointed out, where it is pointed out? It points it out in all the places here, right. So for this 2, what value I have to take? Already I said that this is taken as single rule, this is taken as single rule with multiple antecedent. For single rule with multiple antecedent, what I have to take? I have to take the minimum value. So I have taken the minimum value in order to arrive c1, right. Let me take to the second one. My rule is x is a2 and y is b2. Now my x is a dash and y is b dash is given. If you take this x is a dash here, the common value is here. Likewise b is taken, the common value is here, it gets get. Out of these two, this is a maximum value and this is the minimum value. So I have to go for the minimum value to derive c2. Now I got c1 and c2. From this c1 and c2, what value I have to take? I have to take the maximum, that means I have to take a union. So union means this value and that value, see, this value is here and this value is here. So this is the maximum. So whenever you are discussing with max, it is union. Whenever you are saying the word min, it is intersection. So when you want to fire the system with the multiple rules and multiple antecedent, each rule has to be fired like a single rule with the multiple antecedent to take the minimum value to arrive C1 and C2, and overall from the C1 and C2 you should take the maximum value, and that is the final compositional rule of inference to say about the multiple rules with the multiple antecedent. So this is what about how a multiple rule with the multiple antecedent is getting executed, right. So with this few note, I think you can easily understood the idea behind the fuzzy reasoning, right. So what is the idea of fuzzy reasoning? So fuzzy reasoning is nothing but when you want to provide a rule and it should be defined as a relation, that means binary fuzzy relation, then it is going to be fuzzy if then rule. For the fuzzy if then rule, you may have a two tasks called coupling and entailing. Followed by coupling and entailing, you have a compositional rule of inference. Based on the compositional rule of inference, you need to derive a reasoning mechanism for executing the rules. For understanding the fuzzy reasoning mechanism, you have single rule with the single antecedent, multiple single rule with the multiple antecedent, and a multiple rule with multiple antecedents. So based on this prerequisite information or idea about how the compositional rule of inference is working, our next topic is to dealt with fuzzy inference system. So thank you.